are represented in these two square brackets, or sometimes some textbooks follow this big braces. Okay, and always it's a practice to specify something like this, m into n, meaning m stands for number of rows and n stands for number of columns. This is a standard notation across the universe. So if somebody says, I have a matrix called A, something like this, 1, 2, 3, 4, 5, 6, 7, 8, 9. This each one is a row. This is row 1, row 2, row 3. This is x1, x2, x3. That means column x1, column x2, column x3. You can name it anything that you want. Okay. Now, I have to remind you once again, your database is nothing but rows and columns. Hence, we need to really focus ourselves to understand these matrices. As we move along in a few minutes, you will know how beautiful it will help us to play with the data. So there is a matrix type called square matrix. When do you call a matrix A as a square matrix? Very simple. If my m equals to n, this is your mn, right? Then you call this as a square matrix. If m equals to n, that means number of rows equals to number of columns, then that matrix is called as a square matrix. 1, 2, 3, 4 is a square matrix. This one is a square matrix, right? So your number of rows and number of columns are equal. That's when you call the matrix as a square matrix. Fair enough? Suppose if m equals to not n, m not equals to n, then it is not a square matrix. Not a square matrix. Fair enough, guys? Okay. Now let us look at the column matrix. When do you call any matrix as a column matrix? Any idea? When m can be any, n can be only one, then it is called column matrix. That means A equals to something like this, 1, 2, 3, 4. This is 4 by 1. This is the dimension. That means this n is always 1. It can have n number of rows. N number of rows. M can be any number of any number. Similarly, row matrix. In row matrix, m is always 1, n can be any. Then it is called row matrix. It is something like A equals to 1, 2, 3, 4, whatever. Okay. Now I have a question for all of you. What kind of a matrix is this? Please respond. What kind of a matrix? Friends, what happened? Are you with me? Single row, single column. When you have something like this can be either column matrix or a row matrix. It satisfies both the conditions. Singular matrix, we will talk, we will come to that. 1 minute. Within a minute, we will come to that point, Arvind. Okay? Oh, wonderful. Now, suppose I wanted to have a statistics. Let's say I collected the data of this particular class. So, person, let's say Krutik, Arvind, Ravi. So I am calculating, let's say, uh, height, weight, age. Height, weight, age of a person. That is what we are trying to calculate. So height, I'll say, okay, Krutik, 5.8, weight about 60 kgs, age probably 22. Arvind, maybe 5.5, weight will be 58 or 56, age could be 21. Ravi, probably height will be 5.10, weight will be around, let's say, 67, and age will be, let's say, about 28, something like this. If the data is given like this, how do you represent this data in the form of a matrix? Any idea, my dear friends? Three by three, yes. So this is something like this horizontal row. Remember this is called observation. What is this? Horizontal row is observation. It is all, in the statistics, always observation is represented in the form of a column matrix. Remember, I am writing it in the red color. Column matrix, observation always represented in column matrix. Remember this. Keep this in your mind. That means for any given person, what it will be, if you look into what you call, sorry, what happened to me? No. See, this is an observation, guys. And observation is something that you always wanted to put it in your column matrix. So how do I represent this? This is your height, weight, and age. Suppose for Krutik, I'll be specifying something like this: 5.8, 60, 22. But each one, each one, each one is a variable. Each one is a variable. Hope you are clear with this definition. Which one is a variable? Which one is a observation? Okay. Now, let us move on. Let's get into transpose of a matrix. Suppose I have A 1, 2, 3, 4, 5, 6, 7, 8, 9 of dimension 3 by 3, or I can call it as m by n dimension. A transpose A transpose is nothing but rows will become columns, columns become rows. That means whatever the matrix that you have, your dimension become n by m. Please understand this. Here the dimension is m by n. Transpose is nothing but rows will become columns and column becomes rows. That is your transpose. So in this case, what will happen? A transpose is nothing but 1, 4, 7, 2, 5, 8, 3, 6, 9 is your transpose, A transpose. Okay. Now, another definition, symmetric matrix. What is this symmetric matrix? Suppose you have a vector matrix A. When do you call a matrix as a symmetric matrix? There is a property. If A equals to A transpose, then A is called symmetric matrix. Okay. If A equals to A transpose, then A is called symmetric matrix. That means, in other words, it is actually putting some kind of a constraint on the matrix A, stating that this is only possible, this is only possible if A is a square matrix. So there are two conditions if you want to see a matrix A to be symmetric. One is it should be square and it should be this A equals to A transpose. Then only you call that as a symmetric matrix. For example, let's say A is, you have something like this: 1, 2, 3, 4, 5, 6. So if I do A transpose, what will happen? It is 1, 2, 3, 4, 5, 6. So A is not equal to A transpose. That means A is not a symmetric matrix. Friends, very simple. Are you with me? Okay. Now, let's say you have A. First of all, this itself is not a square matrix because this is 2 rows, 3 columns. So square matrix is nothing but M equals to N. That means it should be 3 by 3 or 2 by 2. Let's say you have a matrix something like this. 1, 2, 2, 4. This is a square matrix because this is 2 by 2. Now what will happen to my A transpose? A transpose again 1, 2, 2, 4. So A is satisfying this condition. So it is a square matrix and it is satisfying this condition. Hence A is called symmetric matrix. Is that fine? Guys, are you understanding? Are you with me? Any question? Wonderful. Okay. Moving on. Another definition you need to know. Diagonal matrix. Sorry. Diagonal matrix. Any matrix, okay? Any matrix. Let's say you have a matrix A. Let's say 4, 0, 0, 0, 5, 0, 0, 0, 6. So diagonal matrix, it is possible only for a, I mean, for that matter, anything. It is the conditions are like this. Symmetric. First, it should be symmetric. The matrix should be symmetric. Second condition, diagonal elements are non-zero elements. Third, off diagonal elements are zero. See here, they are all zeros, right? These are all called off diagonal. This is diagonal. 4, 5, 6 are in diagonal shape. I mean, they are in the diagonal arrangement, right? So this one you call them as a diagonal elements. Okay. Now let us look into the definition of another identity matrix. Identity matrix, usually defined by or identified by capital I. If the diagonal elements of any matrix, are 1 and their off diagonal elements are zeros, then it is called as identity matrix. Identity matrix, okay? Two definition, I mean, from a definition standpoint, first, it should be square matrix. Second, it should be symmetric matrix. Third, diagonal elements are 1. Okay, so there are little bit of some fundamentals with respect to matrices. There are few more matrices, types of matrix, which we will learn in another 10 minutes time frame. Oh. But before going there, let us look at few operations that are possible on matrices. What are the various operations that you can actually perform on matrices. 1. You can do addition. You can do subtraction. You can do multiplication. Fourth, you can do inverse. Fifth, division is not possible. Please remember and store it in your mind. Okay? Now let us look at addition. Suppose you have a matrix A, m into n. So A dimension is m into n. Or rather, let me put it this way. A equals to something like this, m into n. And there is another matrix B, P into Q. A plus B is possible if and only if m equals to P, n equals to Q. If this is not satisfied, then you cannot do addition. Okay? Suppose, example, A, let's say 1, 2, 3, 4, 5, 6. B, let's say 0, 1, 2, 3, 4, 1. So this is 3 by 2. This is 3 by 2. So your M is matching, your N is matching. Hence, addition is possible. What will be the addition? The resultant matrix is A plus B equals to, simple. You add each element with respect to its corresponding element in the other matrix. That means 1 plus 0. This one first. Next, second one. 2 plus 1. Third one. 3 plus 2. 4 plus 3. 5 plus 4. 6 plus 1. This is the resultant of the A plus B. If it is a subtraction, simple. All you have to do is you simply use subtraction here. Okay? Guys, any questions? Okay. So A is equal to 1, 2, 3. B equal to 1, 2, 3. A plus B equals to not possible, because this is 1 by 3 matrix. This is 3 by 1 matrix. So your M is not equal to P, Q is not equal to N. Okay? Now look into multiplication. Suppose you have matrix A. Oh, not. Yeah. There are two matrices. One is A, another one is B. A equals to m into n, A equals to m into n, and B equals to P into Q. Okay. A star B, that means multiplication only possible. Multiplication is only possible when n equals to P. Please remember. That means this becomes this. Okay. And the product of A into B is nothing but m dimension m into Q. That means this one and this one. This is the fundamental principle that needs to be satisfied if you want to do multiplication of two matrices. Let's say you have a matrix A 3, 2, 1, 4, 3, 2, 1, 4. Let's have some other element also, 5, 6 probably. And now you have a B, something like 1, 2, 1, 4. So this is nothing but 3 into 2 dimension. Here 2 into 2. This and this matching, and the resultant is going to be 3 by 2 matrix. So what you do? A star B, this is how you do it. What you do, A star B, is basically first you will be taking this first you will be taking these two, first row with first column. So what you do? 3 multiplied by 1, 3 into 1 plus 2 into 1. Next, second row, okay, you have to go everywhere. It is something like this. This one into this. Next one, this one into the second column. So what you do? 3 into 2 plus 2 into 4. Next, second row, first column, 1 into 1 plus 4 into 1, 1 into 2 plus 4 into 4. Third row, first column, 5 into 1 plus 6 into 1, 5 into 2 plus 6 into 4. This is nothing but your 3 plus 2, 5, 1 plus 4, another 5, 5 into 6, 11. This one is 6, 14. Now what is the one? 3 into 6, 6 plus 8, 14. 2 plus 8, 10, 34. This is 3 by 2. You got it right? This is 3, this is 2 dimension. This is how you do the multiplication. Any questions, my dear friends? Can you guys do B into A and tell me what is the answer? B star A. B is 2 by 2 matrix. A is 3 by matrix. So the definition is this N should be equal to P. This is not matching. So B into A, that means matrix multiplication between B and A matrix is not possible. Meaning AB not necessarily should be equal to BA. Please remember. Friends, is it clear to you all? Any confusion? Yes. Any confusion? Clear? Okay. Now, there are certain things. Okay. Let me define you. Let me give you two matrices. A. 1, 2, minus 1, 1, 3, 1. B. 1 by 1. Okay. You guys have to know, you need to do this. Rather, I will name this, I'll change the names here. This I will call it as X. This I will call it as Y. So slowly I'm taking you into the matrix algebra. Okay. X transpose X. 2. X transpose X multiplied by X transpose into Y. 3. X multiplied by X transpose X and X transpose. You need to by heart these are the formulas for something else. They represent something in machine learning. Okay, you keep on listening to a word called betas in machine learning. So these are some of these are the definitions of those betas. X transpose Y. Fifth one, Y transpose X. Sixth one, X into X transpose. Do this as a homework, my dear friends. When you get into the actual machine learning learning, then you will know the importance of these things. Okay. That time anyway we have to talk about when we use the word beta. Okay. Now let's go a little more deeper into matrices. This is, what is this? Determinant of matrix. determinant of matrix. Suppose if you have a matrix something like A, B, C, D. These are the A, B, C, D are the elements. Then determinant A is nothing but AD minus BC. That means subtraction of the diagonal elements. AD minus BC. Remember, this is not a modulus. Modulus means modulus of minus 2 is 2. Determinant of A is either positive number or a negative number. Please remember, this is very important. There is a confusion to many people. Okay. So when you say you have example, let's say 2, 3, 1, 4, then determinant of A is nothing but 2 into 4 minus 1 into 3. That is 8 minus 3, which is 5. Remember, determinant of a matrix can be a negative number also. However, one important, very important definition that you need to remember when we talk about determinant of a matrix is determinant of matrix modulus A is possible if and only if A is a square matrix. If it is not a square matrix, then you cannot calculate determinant. Please remember. Moving on, there is another matrix called singular matrix. Any matrix, for that, any matrix becomes singular matrix provided if the determinant equals to 0 and the matrix is a square matrix, then it is a singular matrix. What is this? Then A is a singular matrix. A is a singular matrix. This condition has to satisfy. If when is this determinant A is possible? When the A is a square matrix. To the square matrix, you can calculate the determinant, and if that determinant becomes the 0, then it is called a singular matrix. That means, let's say, for example, you have a definition of, let's say, 1, 2, 2, 4. This is a square matrix. This column is x1 column, this column is x2 column. I'm talking about in terms of columns now. When the determinant, if I calculate the determinant, what will the value? 1 into 4 minus 2 into 2, which is 4 minus 4, which is nothing but 0. When determinant of a matrix, any matrix becomes 0, then the inference which you can take it is x1 column, x2 columns are highly correlated. I'm using the word, please remember the highly correlated. Correlation. In R you use this, right? Core. The core in R programming. Okay. The correlated is, this statement is very powerful and very important. Especially when you get into the machine learning and when you are trying to do the regression analysis, you need to identify the columns in such a way that the columns are always highly independent. They cannot be dependent. If they are dependent, then they have a high correlation value exist between them. You have to come out of this high correlation when you are doing the analysis using your machine learning algorithms. Remember in mind, very powerful and very fundamental basic principle of your machine learning. So when determinant A is not equals to 0, if this is not equals to 0, then you call it as non-singular matrix. It's that simple. Okay? Okay. Moving on. Let's moving on to the inverse. How to calculate? I'm audible, guys. Please respond. Am I audible? Friends, am I audible? Yeah. Okay. Inverse of a matrix. There are two conditions to be satisfied if you want to calculate the inverse of a matrix. First one, the matrix should be square matrix. Second one, it should be non-singular matrix. If that is the case, A inverse is nothing but adjoint A divided by, sorry, adjoint A divided by determinant of A. If it is a singular matrix, determinant of A becomes 0. That means A inverse becomes negative, so infinity. So if the determinant of if the column, when do you say, if you go here, when these two columns x1 x2 are highly correlated, then their determinant becomes the 0. Because it becomes the 0, my A inverse becomes infinity. Hence, in the machine learning, this is going to be a biggest problem. So you need to make sure that it should always, this matrix, your data that you pulled up from various databases or whatever it is for various analysis that you want to do, should always be a non-singular matrix and square matrix. Whatever you want to do. Finally, you have to come to that. Okay? So, this is how you will be working on. Now the question comes. Now I know A inverse. I know this. How do I calculate my adjoint A is the question. Suppose you have elements like this. A is nothing but A, B, C, D. Okay. Adjoint A is very simple. All you have to do is, remember, first interchange the diagonal elements. Okay. After that, change the sign of the other elements. Meaning, this is something like this becomes D, this becomes A, this becomes minus C, this becomes minus B. This is what your adjoint. Is that clear, my dear friend? Okay. Okay. Now let us look at few properties. Properties of these matrices. Very important, guys. A plus or minus B transpose is nothing but A transpose plus or minus B transpose. You can verify. You can take any randomly. You define any of the A, B, C, A, B square matrices, and you can prove this. You can try it out. A into B whole transpose is nothing but B transpose into A transpose. Remember this. There is a big confusion. If you miss this one, whole point will be you will be doing a thorough mistake in your machine learning. Okay? A, B, C transpose is nothing but C transpose into B transpose into A transpose. These are all the, we don't need to really spend on proving all these things, but these are all the properties you should remember, kept in your mind. You can't forget this. A inverse is nothing but A. Same thing in the same direction, another corollary kind of a thing which you can call it as A transpose equals to A. A multiplied by B inverse is nothing but B inverse multiplied by A inverse. This also you have to remember. Sixth one. A transpose minus 1 equals to A inverse transpose. Sorry, I said minus 1. It's not minus 1. It's inverse. A transpose inverse equals to A inverse transpose. 7. Identity matrix multiplied by any matrix is nothing but A into I equals to A. This AI is the identity matrix. Eighth one. A inverse into A equals to A into A inverse equals to identity matrix. Okay. X transpose X is always symmetric. We will see whether it becomes I or not or whatever it is, but this is something which you need to keep it in mind. Okay. So guys, can I take 5 more minutes, little more extra, so that I can show you these things in R? Is that okay? Please respond. Can I take 5 to 10 more minutes extra? Wonderful. Thank you. I'm logging into R Studio. Please, all of you log into R Studio. Are you able to see my screen, my dear friends? Wonderful. So I am defining a matrix A. How do I define a matrix? Simple. We know this, right? Magic. I'm creating a matrix is the command. So I'm using the concat function 1, 2, 4. This is for illustration perspective, guys. Otherwise, we can read it from the file and do whatever we want to do. Just to make you understand how you can create these things, I'm trying to show you this. Number of rows equals to 2. N row equals to 2. So now A is created. See here, A is created 1, 2, 3, 4. Okay. Now I want to calculate transpose. Let's say simple. T stands for transpose. Within the brackets, within the braces, you can say capital A. You say done. Job is done. The rows have been converted into columns. Columns have been converted into rows. Any problem, my dear friends? This is what a transpose. Suppose I am creating another matrix B, okay, using the same matrix function. Let's say concat, say 5, 6, 7, 8, and n row equals to, let's say 2. Again, this one also. How my B is going to look like? This is what my B is going to look like. Now, I can simply say A plus B. See, this is A and this is B. 5 plus 1, 6, right? 6 plus 2, 8. So straight away, it has done the calculation. Okay. Now, if I say A into B, what will system will tell? System will be telling you object is not found. So how to do the multiplication? There is a way here. A, okay, percentage symbol, star, percentage, and B. So basically multiplication star is something you have to put it in the, you have to enclose the star symbol between with percentage symbol. Percentage star percentage will basically gives you the multiplication. See the multiplication system beautifully done the multiplication. Okay. Now I want to find out the transpose. I can transpose of this also is possible. See transpose small t capital of, let's say A transpose of A into B is something which I am looking at. Possible. Okay. Now transpose of B see here AB is not equal to BA. Are you clear with that perspective? And transpose is also is not matching. Any doubt here till here, friends? Any doubt? Any questions? Please respond. Anything? Any doubt here? Are you with me, guys? Or you are busy in making notes? Okay. Shall I move on? Okay. Now I want to calculate the A inverse. How do I do that? There is a command called solve. Solve is the command which will calculate you the A inverse. This solve A is nothing but A inverse, which is nothing but adjoint A by determinant A. This is how it is system is going to calculate. Solve is the another command which you need to remember. Okay, fair enough. Now suppose I want to calculate A transpose A transpose into A, or X transpose into X, or B transpose into B. What should I do? There is a, if I want to calculate A transpose A, so here you can, there is a command called cross product. Cross product A means A transpose multiplied by A. That's what it means. Cross product of B. That means B transpose into B. If I want to calculate determinant, simply say det A. Done. Your determinant is calculated. So you remember how to do multiplication. You should remember what is the solve. Solve is nothing but universe. Cross product is nothing but same matrix transpose multiplied by same matrix. B transpose into B, A transpose into A, X transpose into X. Okay. So there is another command called diag A. Diag A will actually fetch you the diagonal elements. Diag A will always fetch you the diagonal elements. Is that clear, my dear friends? Okay. Okay. So 6 more months over. Okay. I will stop it here, and then what we will do is we will tomorrow. Not tomorrow. Tomorrow is a holiday for you, right? Yeah, Wednesday. Thursday morning 7 to 8 we can join. Morning 7 to 8. Request you to join. I'll be taking you through the coordinate geometry and yeah, coordinate geometry and little bit of calculus basics and few more definitions of matrices, so that it will be easy for you when you get into your machine learning. Any questions, my dear friends? No questions? Okay, then see you guys tomorrow. Not tomorrow, it's on Thursday.